Hello guys, welcome back to today's session. So I want us to do this analytical geometry problem, and then there's something important, especially 4.3. Stick around until we do 4.3 because these issues of angles, it bothers a lot of people. So there's something that I want to show you in this video. Otherwise, if you want to join the exam focus program, that's actually going to start it has actually started this Monday. It will go on until you write your final examination. Ensure that you text me on this WhatsApp number, as well as if you want to request for a one-on-one session. Otherwise, let's actually start with this question. Okay, so we are having this circle, right? So it's actually having the diameter VW, and then a P is actually the center of the circle, and we're having the vertices W, V, C, and B that are actually, on the circumference of the circle, as well as we are actually having this line TC. So TC is not the tangent because it is actually touching the circle at exactly 2 points. If it was touching the circle at 1 point, it could have then became a tangent. Now we learned that the radius of the circle is actually root of 10. So they say find K, V is on the right to P. So they want us to find the value of K. How can we do that? How can we quickly find the value of K? So this is what we should do. We are going to use, the equation of the circle, the formula for the equation of the circle. We know it's equals to x minus a squared equals to y minus b squared equals to r squared. So this is just the radius squared. So what is the value of x? So x is going to be k, and then a, it's going to be minus 3. So since it's minus, when it comes here, it's going to be a positive. So it's going to be a positive 3. And then we're going to square it plus. So the y is going to be 1, and then the b, it's going to be minus 4. And then we square it. But what is r? So r is the square root of radius. So if the radius is root of 10, so we're just going to square this. So it's just going to give us 10. Now we're going to have k plus 3, and then we square it. We're going to have what? Minus 3, and then we square it. That is actually going to give us the value of 10, right? Now we are left with k plus 3, and then we square it. That actually equals to 9. That actually equals to 10. So we're actually having k plus 3, and then we square it. If we take the 9 to the other side, we end up having 10 minus 9, and we all know that is actually going to be 1. So what do we do from this point? We're actually going to put the square root on both sides. So that tells us that we're going to have k plus 3. That actually equals to plus or minus 1. So let's actually look at this. We are having the positive 1 and we're having the minus 1. So let's actually separate them. We're going to have k plus 3. That equals to the positive 1. Or we're going to have k plus 3. That actually equals to the minus 1. So if we take this to the other side, we're going to have k that actually equals to minus 2. Or k, if we take this to the other side, we find that it's going to equals to minus 4. But which one is the value of k? How can we decide it? How can we conclude which one is the value of k? Well, if we go back to the question, it says that find k, and they are telling us that v is on the right to p. So which one is the right? So my side, this one is my left, and this side, it's going to be my right. So they're telling me that v is actually on the right side, so to p. So if this is minus 3, we need to push this to be on the right. So it has to be minus 3. So the value of k, it has to be less than minus 3. So it means that it is going to be minus 2. So we can conclude that therefore k equals to minus 2, not minus 4. Why? Because it has to be to the right. So if we take it to the other side, it is going to be less than, minus 3. So it's actually minus 2. Okay. Let's actually look at this question. We are given the equation of the circle in this magnitude, and they want us to find b and c. Oh, they just want us to find the distance BC, but we are given the equation of the circle. Well, I want to go out of my way. I just want to teach you guys just to see the opportunity. I want us to convert this equation onto x minus a squared plus y minus b squared equals to r squared. How can we change this expression and write it in this way? I just want to teach you how to complete a square. So if I copy it, I'm having x squared plus 6x plus y squared minus 8y. Let's just take the 15 to the other side. We're going to have minus 1/5. So this is what you do. You're going to say x squared plus, you are having the 6x. Take the number that is actually in here and you said plus 6, you divide it by 2 and then you square it. That's what you do each and every single time. Now you're having y squared minus 8y plus, what am I going to do? I'm going to take this number, it's minus 8, I divide it by 2 and then I square it. What am I having? I'm having minus 1/5. So math says whatever you do on the left, you also have to do it on the right to ensure that your formula is balanced. But not just to balance the formula, it's because you want to keep everything constant. So the best way to keep everything constant is you need to add on both sides. So on the left, you have added 6 divided by 2 and then you square it. So it means even on this side, you need to add 8 divided by 2 and then you square it. So this is what you want to do. I want us to look at this expression of x. So what you want to do is you are having x squared, just write it as x. You are having 6 plus 6 divided by 2 and then just write it as positive 3 and then you square it. So what you have done is if you expand this exponent, if you expand this, these binomials, they're actually going to get you back to this original expression. So we want to do the same thing with y. So we're going to say plus y, you're going to say minus 8 divided by 2, it's going to give you minus 4 and then you just square it. So if you expand this, it will actually take you back here. And then what did you add to the other side? I want to use my calculator. You're going to say minus 1/5 plus 6 divided by 2, you square it, plus minus 8 divided by 2 and then you square it. You're going to find the value of 10. And it makes sense because even on our previous question, we did outline that, r squared is going to be 10, and that is what we get even to this point. So just show you that we are doing the correct things. But let's just go back to the question. The question said we need to calculate the length of BC. How can we do that? How can we calculate the length of BC? So we realize that BC is actually on the y, on the y-axis. And we know that whenever y is a value, x has to be 0. So it means that we come here, since we want to find the values of y, wherever this x, we're just going to put 0. And then we square it. We want to find the values of y. And then we're going to equals this to 10. So 3 squared is just going to be 9. We're going to have 9 plus y minus 4 squared equals to 10. So if you take this one to the other side, you're just going to have y minus 4 squared. That actually equals to 1. So we get what we have got on the previous video, but in this time we're just going to use the value of y. So if we put the square root on both sides, we find that we're having y minus 4 that equals to positive 1, and we're going to find y minus 4 that equals to minus 1. So if you take this one to the other side, you find that my y is going to equals to 5. And then if you take this one to the other side, you find that your y is going to be minus 1 plus 4. That equals to a positive 3. So what does this tell us? This tells us that the value of c it's going to be 0 and 3. And then the value of b is just going to be 0 and 5. So they want us to calculate the value of BC. What is the distance between b and c? Well, obviously the distance between b and c it's going to be 2 units, because to move from 3 to 5 you add 2, so that's just going to be 2 units. So that is your answer. BC it's 2. Now this is the question that I wanted us to do. They say k equals to minus 2, right? And that is what we have got. Now they're telling us that k equals to minus 2, so they want us to find the value of alpha as well as the value of VWB. So what is VWB? So VWB is actually this angle. I'm just going to call it angle X. Now, let's find alpha first. How can we find the angle of alpha? Well, The angle of alpha, we can just find the gradient of this angle, the gradient of this line. If we find the gradient of this line, we can use the tan theorem to find the gradient of alpha. So what is the gradient of VC? It is going to be y2 minus y1 divided by x2 minus x1. So y2 is going to be 3 minus 1 divided by 0. K, it's positive 2. So we're going to have the value of 2 divided by 2, that's just going to be 1. So it means that the tan of alpha is going to be 1. And what we want to do is we want to find the inverse of tan. And that is just going to give us 45 degrees. So we find that the value of alpha is going to be 45 degrees. And we all know this is always a 90 degrees. Now they want us to find the value of x. When analyzing this question, I saw something interesting. If you look at V, W, B, and C, this is actually a cyclic quadrilateral. And what do we know about cyclic quadrilateral? We know that the exterior angle of a cyclic quad equals to the opposite interior angle of that cyclic quad. So in another word, this angle actually equals to this angle of x. This is the knowledge from Euclidean geometry. So it means that instead of trying to find x directly, you can just find this angle and equate them using the laws of cyclic quadrilaterals. So how do you actually do that? Well, if you check, we're already on triangle TC, it's just TCO, right? So we're just going to say, well, in triangle TCO, that is actually a right angle triangle. We know that if we add 45 degrees, we'd add it with 90 degrees, and then we add it with x. This is going to give us 180 degrees. And the reason to that is because the sum of angles of a triangle is just going to give us 180 degrees. So what is 45 degrees plus 90? So 45 degrees plus 90, you get 135 degrees. This is actually going to equals to x. That actually equals to 180 degrees. So you want to take this into the other side. So the value of x is just going to be 180 degrees minus 135. So that is going to give you the value of 45. So this is just 45 degrees. Well, so if the value of x is 45 degrees, let me just write it. If the value of f is 45 degrees, it means that also this angle as well, it is going to be 45 degrees. So what you want to say is, you're going to say, well, the angle x, it is going to equal to the angle VWB, because the exterior angle of a cyclic quad equals to the opposite interior angle. But there's something interesting that I noticed now. Well, if this angle is 45 degrees, and again, this angle is 45 degrees, it means that these two lines are going to be equal. So if this angle is 45 and this one is 45, using the theorems in Euclidean geometry, it means that these two lines are actually going to be equal. So in another word, if O goes to C and the C is 3, it means that T is going to be 3 and 0. So in that way, you have actually found all the sides and almost all the angles of this shape.